2.5, we are going to talk about secant, or the graphs of cosecant and secant, and then we are also going to do some solving using our graphing calculator. So I want to talk about our graphs for cosecant and secant to begin with. They are the inverse of sine and cosine, so they're like the reverse of it. So I want to talk about cosecant first. First of all, when we had sine, right, y equals sine x. We said one period went out to 2 pi. It always started at 0. Went as high as 1. What do you need? No, she just dropped off some homework. Oh. Okay. Much better today. It must have been. Thank you.
There was yesterday. As long as Ethan's got it in 4-wheel drive, we're all good. I don't think we're only 20 minutes late.
All right, so remember that a sine graph started at 0, went as high as 1, was 0 at pi, went as low as -1, and then went up to 2 pi, right? This was our sine graph. So cosecant, I'm going to put it in red here, any place that there is a 0 becomes an asymptote. So we will have an asymptote at the y-axis, an asymptote at pi, and an asymptote at 2 pi. Then at each of our points here, it is going to approach the asymptote. So we actually end up with a curve that approaches both asymptotes here. We've taken that hill and flipped it the other way. And then this one's going to approach the asymptotes on that end. So it's really just taken our mountain and our valley and flipped them around.
So will they ever, like, one go up and one go down? Or no? I guess they already do.
Yeah. No, it's just the red one. But I'm showing you where it came from. Okay? So when we go to do cosecant, we're going to do y equals the cosecant of x. You're always going to start with wherever your period is. In this case, it's 2 pi. You are going to have 3 asymptotes, the beginning of your period, and the end of your period, and halfway in the middle. So we have an asymptote at the beginning. We have an asymptote at the end. We have an asymptote in the middle. Wherever your amplitude is, in this case it's 1, halfway between 0 and pi is where your amplitude is. It's going to approach both asymptotes on either side. Go ahead and borrow number 30, but I need it back this hour, okay? All right, then halfway between pi and 2 pi, where our amplitude is, we're going to approach both asymptotes. So it is 2 curves, one up, one down. All right, so pretty easy, right? So let's do this. Example number 1. Oops. Example 1. Graph. Y equals 3 cosecant of 2 theta. So first of all, we need our amplitude. Our amplitude here is 3. We need our period. Our period is 2 pi divided by the coefficient on theta. So our period is pi. So for our cosecant graph, we have an asymptote at the beginning. We have an asymptote at pi, because that's the end of our period. We have an asymptote in the middle at pi over 2. Then our amplitude is 2, so halfway between 0 and pi over 2, we're going to put a dot and approach both asymptotes. We go as low as -2, halfway between pi over 2 and pi. We go down to -2 and approach both asymptotes. Oh, 3, sorry, you're right. I'll squeeze a 3 in there. You're my bad. Yeah, thank you. All right, so do me a favor. Let's go ahead and put this. See if you remember how to put this in your graphing calculator. Okay, so first of all, make sure you're radians. When you type this in, it's going to be 3 times 1 over sine 2 theta.
So let's, theta is just x, right?
Yes.
The x would be inside the parentheses.
Correct.
Is that right? You get a bunch all the way across?
Well, because your window isn't set at 0 to pi, it's set at, yeah, one section is your period. Let me see what you got. Make sure. Yeah, see, so you've got a bunch of them going on, but, yeah. So if we went and put our window, and we said our window for the x went from 0 to just pi, we should get 1 period worth, right? Okay. And that's what we're going to need today, is to be able to put it in 1 period worth. Okay? Yeah, so.
But if you change the window.
Right. Yep. So if you went, and so like this one went from 0 to pi. So in our window, if I go from 0 to just pi, second in that one. Yeah. Whoa. Hold on. 0 to pi. Why in the heck did it do that? Right. Maybe. Hold on. Yeah. You have to do 3 parentheses. No, yours still didn't work. What the heck? Oh, you forgot your 2 on here. That's what it is. Oh, yeah.
Okay, mine's also not. Even you've got your 2.
There we go.
You've got your 2. That's it.
Yeah, okay. All right, so we all got the, we're going to be using this today, so I want to make sure we understand how to put that in our calculator. Are we good? Okay, let's move on to secant. Let's talk about secant. So before we do secant, I want to remind you what cosine looked like. Remember that cosine, y equals the cosine of x. Right? Always started at our amplitude, finished at our amplitude. And the middle at pi, it went down to our amplitude, and halfway between, it's where it crosses 0, right? So it did this one wave like that. Hopefully your dot's a little better than mine. Okay, so what do you think happens when we talk about secant? So secant, any place that there's a 0 for cosine becomes an asymptote. So I have an asymptote here, and I have an asymptote here. Where my amplitude is, it's going to start and approach my asymptote. Again, here at the bottom, it's going to approach my asymptotes. And then here, it's going to approach my asymptote. So you actually end up with 2 curves coming in and 1 at the bottom. All right, so let's talk about what it actually looks like now that we've made our cosine inside out. That's kind of what it looks like to me, right? So what secant actually looks like. Secant of x. When you graph it, come out here at your amplitude, and in the middle you go as low as the amplitude. Halfway between is an asymptote, so this one only has 2 asymptotes per period. We start at the first amplitude and it approaches the asymptote. We start at the middle one and it approaches both asymptotes. And then here we approach the asymptote to the left. Okay? That's what we're going to get every time, 2 coming together. If we were to repeat this and do another one, that would continue So another one at the bottom, now when we continue. Okay? So, here is example number 2. Graph. Y equals 1/2 secant of 1/2 theta. So our amplitude is 1/2. Our period is 2 pi divided by 1/2, or what does that equal? 4 pi, good, 4 pi. So when we go to sketch our secant, at 4 pi, you're going to go up to your amplitude, which is only at 1/2. You have 1/2 at the beginning, halfway in the middle, right, which would be at 2 pi. We're going to go down 1/2. What do we put between those dots? Vertical asymptotes. Very good. Vertical asymptotes are right in the middle. In this case, it'd be at pi and 3 pi. And then we approach our asymptotes. From this dot, we're going to go to the right. From this dot, we go both directions. And from this dot, we go to the left. All right, so again, I want you to type this into your graphing calculator. Remember that secant is 1 over cosine. So this is going to be y equals 1/2 times 1 over cosine of 1/2 theta, or 0.5 theta if you want to put it that way. Then change your window into 0 to 4 pi. Yeah, whatever your period is, if you make your window that, you'll be able to see it. Okay? Everybody's got this? Okay. All right. So, after you have, let's see, 1, 2, 3, 4, 5, 6 graphs, and that's all you have to graph today is 6 of them. You have some where you got to talk about the amplitude, the period, the phase shift, and the vertical shift. Do we need to review that? Okay. Then last thing I need to talk about is solving. Solving. Basic. Trig. Using technology. So if I have, for example, let's say sine theta equals 0.7. Okay? What I want you to do is you are going to put sine theta in one y equals. So y equals, the first one is going to be sine theta. y2 is going to be 0.7. What is your period for this one? 2 pi. So make sure your window goes from 0 to 2 pi. Once you graph this, it should look like this in your window. Okay, so what we need to find are where the two of them intersect. So we need to find this point right here, and we need to find this point right here. There are two solutions. So we're going to go second, trace, go down to intersection. Let me get caught up now. All right, did everybody get that far? Okay. Again, I'm getting caught up. Hold on. 2 pi. All right, so what we need to do now is when you go down to intersection, you have to move your cursor so it's flashing on first curve, which would be the sign one. You need your cursor flashing somewhere close to the intersection point, and then you hit enter. Second curve, it's got to be flashing close to the intersection point. Then you hit enter one more time. Okay, so try that. You're going to go second, trace, down to intersect, which is number 5. Move your cursor to the left where it's close to the intersection. Hit enter. Then for the second one, you want it close to the intersection. Hit enter one more time. You should get that x equals 0.775. Did anybody not get that? Then we are going to repeat the process, but this time we have to move our cursor closer to the other intersection point. So we're going to go second and trace, down to intersect. Move your cursor on the first curve closer to where they intersect. Move it on the second curve closer to where it intersects. And enter one more time. This time what you get for our second x equals? 366. Make sure you go 3 decimal places, okay? Ooh, try it again. Okay, let me see. Yeah, first it goes on the first circle, then you hit enter, then it goes to the second graph, you hit enter, then you enter one more time. Got it? Okay. All right, so the same thing's going to happen for any of the trig functions. I want 2 solutions for each. So tangent, for example, you're going to have to do 2 waves worth, all right, in order to get 2 solutions. Okay, everybody understand that? So let's do a tangent one real quick and make sure we're good, and I'll get you your worksheet. So here is example, example 3. Directions are just going to say solve from 0 less than or equal to theta less than or equal to 2 pi. So you might as well set your window at 2 pi right from the beginning. 0 to 2 pi. And we are going to go with the tangent of theta equals negative 0.37. Alright, so you should have something that kind of looks like this, and then it looks like this, and then it looks like this. And then you get a line that comes over right here, so you can see the 2 spots it crosses, right? So we're looking for the 2 intersection points. So we're going to go second trace. Down to intersect. You want to make sure you're close on both of them. For the first intersection point, I get x equals 2.787. Then try and see if you can get the second one. 5.92. Yeah. So does anybody have a question how that works? We're all good? This is really an important little key here as we move forward. Okay.